Hello everybody, thank you for joining us today. My name is Munam and today we're going to be looking at the national grid. So some of our learning objectives include to understand that the national grid is just a collection of cables, transformers and generators, and to also be able to explain each step of the national grid. So if you're ready, let's get right into it. Alright, so here I have a simplified diagram of the entire national grid. Let's start off here at the power station. Let's do all the writing over here. Okay, there are some key facts I need to know about power stations. That power stations work on using heat to generate steam. Actually, let's do it down. Generate steam, which turns a turbine. So a turbine is what actually does the power generation. In fact, I'm going to cover them in later videos to do with electromagnetic induction. Turning a turbine, and that produces power. Okay, another thing that you need to know about power stations is that they're usually running well below capacity. What does that mean? So if a power generator can generate, say, 1,000,000 joules, like its maximum output would be 1,000,000 joules, it's not always going to be producing 1,000,000 joules. In fact, it might only be producing 500,000, 1/4 that's because that allows to increase capacity for peak times. So what are peak times? So peak times are such as around 3-4 o'clock, when a lot of people are getting home from school, they're turning on their TVs, they're turning on their kettles. Suddenly across the entire country the power demand is surging at around 3-4 o'clock, or in fact around the time EastEnders comes on. You know, EastEnders is a hugely watched TV show in the UK, so everyone's all turning on their TVs and their kettles at the exact same time. So the power station will need some spare capacity to increase its output to meet all of that extra demand. Okay, then we go to something called a step-up transformer. So step-up transformers, well, step up, they increase the voltage of produced power through transformers, right? They transform the lower voltage to an extreme high voltage, and then from there it goes to the long distance pylons. So pylons carry the electricity. Okay, but now let's understand why the voltage is actually stepped up. If we look at our power equation, E is equal to IV. Now, to get a very high power, we can either have an extremely high current or an extremely high voltage. What's the problem with having extremely high current? Well, when you have an extremely high current, the charge carriers, the electrons, they collide with the lattice ions of the actual wire itself, so the conductor, and they transfer energy to those lattice ions. Now those ions, they vibrate even more vigorously, so the temperature of the wire increases, so you lose an extreme amount of energy to just heating in the wire. So and there's actually an equation for that. That's power dissipation is equal to I squared multiplied by R. So if you have an extremely high current to deliver the power, you get extremely high heating effects, so a lot of power is wasted. So rather than having high current, we have high voltage in the step-up transformer, as you can see right here. So those are around 400 kilovolts, 400,000 volts. Now, after the long distance pylons transport those that electricity efficiently, we reach a step down transformer. So this decreases the voltage and increases currents to more useful levels, okay? Because nothing can run on 400,000 watts, right? So we need to step it down to more manageable levels, and then to around 33 kilovolts. Okay, from there, from then on, it goes to like factories at that same voltage, okay, or it goes to another step down transformer. So these are actually called substations. Substation steps down voltage further to 230 volts at 50 hertz, which is what comes out of the mains plugs in our homes here. So now those are all the steps of the national grid. Take a blank piece of paper and pause this video and see if you can write out this entire stage and why, because you will get long worded questions, but maybe 6 markers on this entire process from memory. If you can, well done, you now understand the national grid.